All right. So here, this is our second lecture. If you missed the first lecture or if you want to review the material, there's a link right here on the course webpage to a video. So I recorded my desktop and my voice last time. So I'll continue doing that to make it easy for people that can't make it in or miss the class or want to review the material. So if you look at the syllabus one more time, these are the topics. And I'm going to check you off as you master each topic. And I'll check your comprehension of the topics by meeting with you during lab or outside of lab, so all right as well. And you can complete these topics at any pace that you like. Just meet with me, talk to me, show me some of your work, answer some of my questions, and then I can determine whether you've completed enough, achieved enough understanding of that topic. And the first topic to get over with is this HTTP. I'm not going to emphasize this, so you want to get this done like right away. Okay, so today I'm going to talk about HTTP. Probably today is the first and last day I'll talk about it. And if you don't understand it after today's lecture, then you'll need to do a little reading about it. It's not that tough. I don't need you to go too deep on it, although it's not that deep. So, well, it can get deep. It can get extensive. But it's something that web developers really need to know. The computer scientists, computer programmers need to know. It's security people, video game developers. It's a very important protocol. It's called a Hypertext Transport Protocol. And it's the protocol that is used for web servers and browsers to talk with each other. You know, it's not just web servers or web browsers. You may be running, say, a video game, and that video game may be contacting some server somewhere. Well, it's not a web browser. The video game may be using HTTP to communicate with some remote server. So all kinds of clients connecting to all kinds of servers, and they've just configured or designed to use this particular protocol to communicate with each other. So it's very general purpose and widely used, and important to have some understanding of it. And I wanted to say about, I'm trying to prepare, I'm weak in this area. See, CSS, that's my weak area. And this JavaScript and DOM, this is my strong area. Well, HTTP is my strong area as well. HTML is kind of trivial, so it's not a big deal. It's easy. But CSS is massive, and it's so complicated now, and I really haven't been keeping up with it very well. And but I understand the fundamentals of it, and I see a little bit of what's going on recently. So I can lecture on it, and I can work with it, and but I am a little weak in that area. But you should think about, what you want to do with your career and what you want to focus on. If you like design, if you like web page design, if you like layout, picking colors and patterns and menu systems and building a front end to websites or web applications, then CSS is an area that you need to master. I mean, totally master, and you've got to pour a ton of time and energy into it to get it figured out, if that's what you want to do. If you're more interested in the back end or applications that are not, not front end web applications, maybe back end basically. Not back end, I'm sorry. Well, the JavaScript language, that's also a front end technology, but it's also used on the back end. And it's used in other contexts. It's used in video game engines and well, there may be other contexts, but certainly video game engines, like Unity, for instance, has a JavaScript option that you can program in. All right, so that's my, and what I wanted to say that you kind of decide between putting how much energy you want to put into the CSS. You should let me know when I talk to you, and I'll find out if that's where you want to put your emphasis. And if you do, then I won't expect too much out of this, although this is highly important if you want to be a front-end developer, very, very important. But this is so time-consuming that if you're just starting out, you might end up spending a lot of time on this. If you have like artistic interests, that you like the art side of these technologies, and that's how you want to work, then you're going to want to master the CSS. All right. So HTTP, the Hypertext Transport Protocol. And I was practicing just before coming here on doing some demonstrations, so I'm going to go forward with that. Make this a little bigger. So we'll just do a little hacking together here. And here's some of the work that we did last time. And I'll work in a folder. I'll create a folder called HTTP. And I'm going to write a client, and then in JavaScript running under Node.js, and we'll try connecting to different web servers and play around with the messages that we send to the web server and look at what the server sends back to us. So there's a package, or not a package, a module in Node.js called net, and we import that package using the require function. And then remember, we can print things using this console log statement. So I'm just going to test that. Let's see that that's working. All right, there it is. There's our program, main.js, and we run it like this: node main.js. So okay. All right, so I just do things a step at a time. So what we'll try to do last time we looked at this web server, right? So when we ran the web server, ran it like this, and then we could contact this web server. Well, let me kill this first. So this index.html file, look at that. It just says, it's got a level 1 heading that says hi, and it has a paragraph that says bye. Well, let's retrieve that from our web server running locally on our machine. So run the web server. Go to localhost port 9999 /index.html. There it is. You know, in your browser, there's usually some kind of a facility that is used by web developers to examine the details of what's going on in the web page and the transactions that you're making with a server. And so I've just popped this open here. This is Chrome, and Firefox, Safari, and all the web browsers, they have some kind of facility like this. They all look a little bit differently, but they have the essential same functions in them. And here under this tab in Chrome, you've got this network. Let's see. I can't remember how to do this. Let's see if I refresh. There it is. So here's the object that we requested. And it shows these things called headers. And this is the response here. See that? See the response? This is the data that the server sent back to us. See, that's the H1 tag there. Let me see if I can make that bigger. There we go. And there's the hi and the bye. This is the response, the data. So remember, the browser sends a request to the server, and the server sends a response. So it's request, response. Request, it's called a request response protocol. And this section of the interface is showing the data that was returned in the response. So the response, the data, is preceded by a number of headers. And these are strings. Here's an example. Let's see if I make this a little bigger. These are the response headers, and this is the request headers. I'm going to do view source on that, it's easier. So that first, the browser makes what's called a TCP connection to the server. Once it establishes this TCP connection, it's called a Transport Control Protocol, TCP. It's an internet protocol. And HTTP, that protocol is implemented on top of this TCP protocol. But the TCP protocol is implemented on top of the IP protocol. The IP protocol is implemented on top of, and that's called a stack. You got these protocols that basically rely on or operate, they operate on top of some other protocols. You get down to the bottom where you have the physical layer where information is being sent physically. So that's a topic that's covered in data communications class here. That's which we're not going to go into. So once this so-called TCP connection is made from the browser to the server, so it's the browser that initiates the connection. Right? The browser goes out to the server, so that's what a server is called, a client. And then the server is going to wait for the client to send a message. Once a connection is made, the server is just saying, okay, what do you want me to do? I'm listening. And the client sends a request message. And it sends these lines, this character data. So this is the first line is the I forget what you call it, the request header. I can't remember. Anyway, there's this HTTP protocol has a number of different methods. Not very many. And one of the methods is the get method. So you see the three letters right there, get. So this is an invocation of the get method. Not exactly an invocation, but a selection of the get method. So the client, the browser, wants to get something. And what does it want to get? So that's the first field in this first header. The second field is it's the name of the resource that you want to get. So it looks like a file. In our case, it's a file. The slash means start at the top of this hierarchy. And it's kind of like a naming hierarchy. And then index.html, it's the name of a file. Then you have a space here. Then you have the protocol version, HTTP/1.1. That's the current version of this HTTP protocol. It hasn't changed for many years. I doubt it's going to change. Previous to this was 1.0. That was used for a number of years. It was replaced by 1.1. Before 1.0 was 0.9. That's it. There was only 3 versions of HTTP. And this pretty much isn't going to be changing as far as I can see. Now you've got some other headers. This is the host header. This is saying, all right, I'm connecting to you servers. Remember the request header, this is the client, the browser talking to the server. And the client says, I want to get index.html. I'm using this protocol, this version of the protocol. And this is the host that I'm connecting to, localhost on port 9999. Now that header right there is required. You have to have that header. Well, you're supposed to. But some servers are forgiving. And if you omit the header, they'll ignore, they won't mind. But some servers will reject the message if the header is not provided. And then there's some other headers. Here's the connection header. It says Keepalive. And that Keepalive header, that came out in the HTTP 1.1 protocol, as well as host. And that means keep the TCP, the underlying TCP connection, keep that active, because I'm going to ask for a web page, but the web page is going to have references to images, style sheets, JavaScript files, and so on. These other objects in the web page, you know, you get the HTML, that's one file, but usually the HTML has image tags in it, for instance. So then the client, after it gets the HTML code, and it says, oh, I see, I got to retrieve 20 images in order to display this HTML file, this web page, display this web page. So as soon as it gets the HTML code, it has to turn around and submit 20 more requests, one for each of the images that are referenced in the web page. And then some other things, some style sheets, some JavaScript, and maybe some fonts and so on. So if you tear down the TCP connection and reestablish it again, there's the cost there. So to be more efficient, just keep the TCP connection open, and we're going to send the other request messages over that same TCP connection. So that was it's kind of like an efficiency that was added to the protocol some years ago. And here's a pragma no cache. This is telling the this is something that's related to caching. Cache control, no cache. I can't remember exactly what the effect of this has. I think it's saying that something. I don't know why the client would be sending that no cache. Maybe it's saying I don't have your page in my cache, something like that. User agent, and here's upgrade insecure request. I don't know what that is. User agent, Mozilla /5.0, Macintosh, right? This is, the user agent is the browser. The browser is identifying itself. And this, you can't trust the user agent because there's a lot of user agent spoofing going on, and sometimes it's done, for good reasons. And some other headers here. These are new headers. I'm not familiar with these. The accept header. This is a list of different kinds of media that the browser can handle. It can handle HTML. It can handle XHTML. It can handle and so on. So that's not too important actually. And some of these other things. Accept encoding. Here, the browser's saying, I'll accept data that's compressed using the Csusb compression algorithm, or deflate, or BR. So these are three different compression techniques. Now, to save on bandwidth, if the data is large, typically the server will compress it to reduce the number of bytes that it gets transmitted over the network. So there's some cost saving if you compress the data going out. So the browser here is saying that it can decompress these three data sent with any one of these three compression techniques. And the language, English, US, and so on. And all this business here, I used to know what this was. It's not that important, so I'm going to omit that. I'm not going to talk about it. So that's the request headers. And then the response headers, I want to view the source there. This is these are the headers that come back from the server to the browser. So the first header is the most important. This is the response header, the status, I think they call it the status line. And it starts with a statement of what protocol it's using. So it's saying I'm also using HTTP/1.1, 1.1 version of HTTP. Then the second argument is a status code. A 200 means everything was good. And then there's a human readable kind of representation of that status code saying, okay, right? 200 means it's okay. You know, if you don't find, maybe you request a document that's not there, then you're going to get a 404 not found response. Let's take a look at that. You know, if I ask for something like, say, this, status, right there. See that? 404 not found. That's the request header. Where is the response header? General response header. There's the status line. That's the code 404. So there's a bunch of different codes in there. There's 300 level codes, 400 level codes, and there are 500 level codes as well. I think if there's a crash on the server side, it usually returns a 500 level code, and so on. It's a redirection operation. It's a 300 level code. There's some grouping there, different kind of messages. A 404, I'm sure most people are familiar with that, right? 404 not found. All right, let's go back to this one. Let's see. So the server returns these headers, powered by Express. I don't know, it sounds like an advertisement header. And accept ranges, I don't know what that is. And cache control, I don't know what this is. Public max age equals 0. Not sure what that is. Last modified, this is the last time that the document was modified. This is probably a timestamp from the file in the file system. And you know, if I change that thing, let's see here. Watch this. That's at index.html. See, that's September 23. This is September 24. Last modified, September 24. I don't get it. Maybe it's like Greenwich Mean Time or something like that. But if I touch this index.html, what do I get? Now it's September 25, went up 2 days. Go ahead and retrieve that again. Last modified September 25. So that's the timestamp on the file. But in your application, if you're not reading a file and you're sending data from a database or something like that, then you're going to need to generate that last modified header. E-tag, this has to do with caching, and I'm not going to get into that. Content type. Oh, here, the content type is an important header. It gives the name of the object that's being retrieved, or the type of object that is being sent. In this case, it's an HTML file. And this label here is called a MIME type. Historically, it comes from email. When an email, you had a multi-part internet message enclosure, something like that, MIME. And these MIME types are originally defined for sending different kinds of data over email, but then it was adopted by the HTTP protocol to describe the type of data that was being returned from servers or submitted from returned from servers. So there's a number of different text types. HTML is a text, it's a stream of character data. So it's text/HTML. And there's other types. For an image, if you send like say a JPEG image, it would be image/JPEG or image/PNG and so on. And the character set, UTF-8, this is the standard default character set of the web. UTF-8. So you see that a lot. And then you have the content length field, 25 bytes. So this file should be 25 bytes in size. There it is right there, see it? 25 bytes. That's the content length. That's the number of bytes. Now the headers are sent. And each header, these are ASCII characters. So these things here, that's C, that's an ASCII 1 byte representation of C, and so on. These are ASCII characters. And at the end of each line is a carriage return and a line feed. The carriage return is ASCII 13. The line feed is ASCII 10. It's a byte with 13 in it, followed by a byte with 10 in it. And at the end of the headers, there's the last headers connection Keepalive here. At the end of the header, so the browser's retrieving the headers, and then it gets to an empty line, which is just a nothing, and then a carriage return line feed by itself. And following that empty line will be 25 bytes of data. So the browser will read 25 bytes of data into some kind of internal buffer, and then process it. So this is how you look at the HTTP headers inside your browser, and this is sometimes useful when you're trying to debug problems. Now, what we want to do is sort of mess a little bit with these headers, and we'll just let's see what we can do on a manual. So let's use TCP directly. And to implement, we're going to implement HTTP ourselves over TCP. So this net module in Node gives you facilities to use TCP on the system. And there's a something called a socket. A socket is this concept that represents the TCP connection. When the client creates a socket, it's just an abstraction, it's just a word that represents that a TCP connection has been established between two endpoints. So you've got, on the client side, the client creates a socket, a TCP socket. Server side, server creates a TCP socket. The two sockets, you can think of them as being connected. This is just, how you think about it. It's just how you model it in your mind. And then you write into the socket and you read from the socket. So you can think of the socket as a hole that goes into the tube that connects to the other end. And you can send a message through the tube and then listen to the tube and get a message coming back. So it's two-way communication. TCP is a two-way communication protocol. And so there is a function in this net module that lets you create a socket. And so it's called connect. And we could give the port number. So I want to make a socket connection to the local host on port 9999. So this connect will establish a TCP connection with the process listening on this port at that address, that internet address, which is localhost. That means the computer that the client is running on. And so this connect function returns a socket object. Now this socket object is inherits the functionality from what's called the I don't know, what do we call it? The event handling interface, something like that in Node. Let me pull that up. So this is the Node net module. So here's the documentation for Node. Class is a socket. And see, the sockets have these events. There's a close event, a connect event, a data event, a drain event, an end event, and so on. Let's see what it says about that. I'm just trying to remember the terminology that they're using there. So in this module, you can create servers, but we're just going to use it for a client, for the client. So here's the connect function. And this is the form that we're using right there, connect port host. Optionally, you can pass in what's called a connect listener, so that this is a function that gets invoked when the connection is established. So it's an event listener. So socket is what's called an event listener. And event listeners have an on function. And the on function, you call the on function to register an event listener for that particular event. So the event we want to listen to is the connect event. And when the connect event occurs, we want our function to run. So we're going to call it, we'll call it the on connect. So we need to have a function named on connect. We'll just print connected when that happens. So we're going to make connection to localhost. And when the TCP connection is established, the system will let us know by calling our onConnect function. And when that happens, we're going to print connected. And I'm not going to print OK here. I'm just going to leave that out. That's enough. We can actually test this code right here. There's the main. So it's node main. I'm in the wrong language here. I don't need to give the data type. This is the variable socket, and that's just a reference to that's stored. That's a reference that connect returns, and it's we just call it socket. And we don't these variables in JavaScript. JavaScript is untyped, and so we don't need to declare a type for that. So I was using like Java, C++ syntax. Const, we could use. In the old days, we'd use var here. We could also use let. If we're going to, this is a JavaScript issue now. So if we want to take this socket variable and reassign something else to it, then we use the let keyword. So let socket equals, but we're not going to do that. We're not going to reassign anything to the socket variable. Once we assign the return value from connect to this variable, then we're going to let it remain constant. So we declare that as const. That's a relatively new syntax in the JavaScript language. So you'll see a lot of code examples you'll be looking at. You'll see var there instead of const or let. And var works fine. But there's some rules that you need to learn about that when you get into it. So anyway, here's the, this will fix the problem. Connected. And look, we're still connected. I think the server is going to time out on us, see? See, the server is, the TCP connection is still connected. Let's see what the server says. Nothing. The server says nothing. And the TCP connection is going to control C. You're going to kill it there, see? See what the server says. Nothing. Okay. So, you know, we don't want it. We want to kill the connection here. After we get connected, then we're just going to drop it. So we would do something like this. Go socket.end. We're going to just kill the connection right there. So then we'll terminate the program now. So we won't get locked up like that. There it is. See that? That's how we do that. Now, once we make the connection, we need to send something. And what we could do is we're going to write a message. We're going to write our HTTP request message. And we want to make sure that when we write in the socket doesn't know, you know, what character encoding to use. So this HTTP request message will be a string. And we have to tell it that we want it to use the ASCII encoding. Once we write the message, then we don't want to close the socket at that point, so we're just going to wait. I'm going to write this message, and let's see what the message is going to look like. Will be like this: const. This will be a string. We'll use the get protocol. We want to get / index.html. And we'll use the HTTP 1.0 protocol. Explain that later. We'll go back one level, one protocol version. So that's that first line. That's the request line in the headers. Every line in that request in the headers must be terminated by carriage return line feed. \r gives you carriage return. That's ASCII 13. \n gives you a line feed. It's ASCII 10. And then it wants the next header. Well, let's not send it any more headers. We got to send a blank line to indicate the end of the headers. That's a minimal message right there. That's a legal message, by the way. If I made this version 1.1, it's not a legal message because it doesn't have the host header. That's required under version 1.1 of HTTP. You have to specify the host header. Like I said, this server doesn't complain about it. I'll just leave it at 1.1. We won't send that host header. We'll put it in there. We'll see if there's any difference. So now we're going to send that request message, but we have to get the response. So we need a function that I'll do on response. We need a function that we can use to call to process the response. I'll call it process response. I'm going to commit this into the repository, so you can keep notes on this, but I'll write this into the repository to be able to access all this code. So we want to process the response, and the response will come in a message. So we're going to print out this response message. And after we print the message, we're going to close the socket. So there's an event when the server is waiting for our request message. So once we send the request message here, then the server is going to respond. And so when it sends data back to us through this TCP channel, that it comes as an event. And the event name is called data. It's a data event. We'll process the response when the data event occurs. We'll have the system call our process response function. And then we're going to print the response message. So we should see headers, blank line, and then the data, the web page, the H1 with the hi, and the paragraph tag and the by. We should see that. So let's see if that works. I'm going to clear first. And there it is. Look at that. It's printing. And so when we print it using this console.log function, it's giving us an instance of a buffer object. These are the ASCII codes, or UTF-8. These are the character codes in UTF-8 of the response. So we want to make that readable to us. So we'll do something like this. We're going to do toString. It's actually what gets returned here is not text, but a buffer object. So because we don't know what it could be, image data. It has to be something generic. So it's just a buffer object, which is like a container of generic data. Yeah.
Where are you declaring or defining the argument, the HTTP response message argument?
The argument, which argument?
The argument that you're passing into the process response function?
This argument here?
Yeah, where is that being
called?
Yeah.
The system calls that. We're not calling it directly. See, what we do here is we register that function. Here, see this function here? We tell the system, we tell the socket that when the data event happens, call that function for us. So it calls it. We don't call it. So we pass a reference. This is like a function pointer. We pass the function pointer to the socket and say, call that function when you get data. So it calls that function. Remember, this is untyped. You don't have a data type there. It doesn't say, buffer space. If it was C++, it would look like this. What's that?
That's just kind of a result of JavaScript being kind of crazy where you don't have
Yeah, untyped. But all scripting languages, Python's the same thing. Lua, whatever. scripting languages are generally untyped. And so you don't provide types. You don't identify your variables as a particular type. You omit that. But the type is buffer. Oops. And I know that because this is how it printed the result. It's telling us the data type, it's a buffer. And then it dumps it does the best it can to show us what it thinks we want to see. It gives us the byte values in the buffer. But we don't want raw byte values. We want it to be a string. So we're going to tell the buffer to take what it's got in it. This is the buffer. And we're going to say, convert that data into a string and pass that to the log function so we can read it. There it is. This is the 200 code. And look at this advertisement in here. See that? X powered by Express. And then these headers are all generated for us. I'm sorry, the server is generating those headers. Look, it knows the content types, HTML. The number of bytes, 25. So connection Keepalive. Well, we closed the socket. Anyways, don't jump too far. So here's the headers. And each one of these lines is terminated by a character return line feed. So the line feed makes it go to the next line. And then look here, right here. This is a blank line right there. That's the end of the header section. Then you have the data section, or the payload. They call it the payload. And that's these bytes here. There's 25 of those bytes. This is probably 12 bytes. Right? That's one, and that's another 12, something like that. And that's it. Well, that's how that works. I'll show you. We'll play a little bit with this connection Keepalive.
What did you change differently?
What did I change? Just the last thing I did. I added 2-string here. This is being recorded, so you can, if you want to get back to this, you can, watch the video. A lot of time is flying, it's going so fast. This time we're not going to close the socket because, it's going to keep the connection alive. You watch the TCP connection, the TCP socket will remain open, so the client won't close because it's got an open connection that's it's waiting on. Let's try that. So I'm going to save this. I took out that socket.end command here. And I'll watch this. You see, we don't have the prompt. The function, it's still continuing, but oh, look, it just terminated now. See, that's because there's a timeout. This is, I'm going to keep alive because you're going to request images and style sheets and all that. So I'm going to keep the TCP connection established, but I'm not going to keep it open forever. I got some kind of timeout value. You know, the system administrator, like if you're a sysadmin person and you're trying to fine tune your web application, you got a lot of, thousands of clients hitting it every 5 minutes or something. You're going to play with things like your Keepalive timeout, things like that, try to optimize on your resources. That's the kind of thing you would tinker with as a system administrator. So it doesn't keep the thing alive forever. It's, I don't know, 5 seconds, 10 seconds, and it says, oh, you're not asking for anything else. I'm not going to waste a socket connection. I'm just going to close it out on you. But on the client side, we could say, we don't want you to keep it alive. And we do that with a header. Let's take a look at that. So here's that blank line at the end. So here's the request message. Now what we're going to do is we're going to put a connection Keepalive. Right? That's what it's assuming. That's the default. So that would be considered the sensible thing to do would be to keep the connection alive. So that's the default. So this here we're going to get the same behavior. It's going to keep the connection alive, but we're not sending any more requests. The server's going to time out. Done. But let's tell the server that from the client side, we don't want you to keep the TCP connection. So we want you to close it. As soon as you send us a response, go ahead and close that underlying TCP connection. So now, when we run the program, it should terminate right away, right, without any waiting. There, see that? Done. So you see, by passing different headers, you're going to get different behaviors. Yeah?
What was the difference between doing the connection off and the socket end and just at the end of your code?
Up here?
Like when you did the socket.end and you removed that earlier, isn't that the same thing as doing connection close?
Yeah, that's right. Yeah, that's right. That's right. It's not as polite, though.
Okay.
It's like, what? You just shut it down on me? Yeah, we're telling it. Oh, we're not going to. Well, you're right. It has the same effect, but probably some little bit different logic executes on the server side, to process that occurrence. It probably doesn't matter. And there's other headings. A very important header is the cookie header. This is very, very important. But we're not going to get into that because it's kind of a topic for server programming. I teach 405 a lot of time. I don't know if we'll teach it next time. I probably will. But when we get into server programming, we're going to look more at these headers and how to, what their effect is. And the cookie header is critical and important. That's how you do things like implement authentication or what's it called? Authorization. So you authenticate somebody and then set a cookie. It's called a session cookie. Then you got a session open and you close the session like that. So that's for another time. That's for another course. I think that's enough for today on, I was going to show you, here, well, one last thing. I was going to do something like this. Watch this. Just another 5 minutes here. We don't need our server anymore. I'm just going to get rid of that. What we're going to do is connect to the CSUSB web server. All right, that's the host. Let's take a look. And we're going to get, I'm going to simplify this get. Just going to request a slash. That's it. Remember what the default on the server end is to request that, use index.html, but sometimes it's called something else. It's something that's configured on the server side. We're going to ask for the root resource. That's like the home page of the university website. And there we go. Let's see what it does. Oh. Yeah, that was a mistake. Web servers don't listen to 9999. The standard port for unencrypted transmission of data is port 80. That's the standard port. So we're going to ask for that port. There it is. Look at this. 400 bad requests. Saying, you sent me a bad request. And look down here. It even tells us what it is. Invalid hostname. It says, look, you said you were going to use version 1.1, but you didn't send me a hostname. So you sent me an invalid request message. But see, the node server, the Express web server, it was forgiving. It didn't mind. You didn't follow the protocol, but we're okay with that. And that's typical in a web development situation, is that you got servers have different behaviors, but the main problem is that browsers have different behaviors. So you make a web page that works really nicely on Chrome, but then on Safari it's broken, right? Because they implement something a little differently. So that is a kind of an issue that you got to deal with when you do web programming. So let's fix this problem. We got to send the host name, the host header. It's complaining about this host header. There it is. That's the host, right? That's the host that we connected to. It says he wants to know, you connected to port 80, but how did you get here? And the reason for that is because that web server is listening. It's bound to that port and at a specific IP address. Now, how does the client get the IP address? It uses a DNS system. So it takes this name here, CSUSB, sends it to the DNS system, and the DNS system says, oh, it's 127.99.43.16. You know, it sends back a number. It says that's how you get to that address. But it's possible to have different domain names that map to the same address. So the web server wants to know, are you coming at me through csusb.edu? Or are you coming at me through other.net? Or are you coming at me through, mysite.com? So all of those domain names may be directed to the same IP address. But the web server wants to know, which one did you use to get there? And that's the purpose of the hosting. So it's called a multi-homing host. Maybe the term is a little different than that. It's been many years since I used it. So let's, now we're adhering to the protocol. Let's see if that fixes the problem. Yeah, we didn't get a, bad request response, did we? Well, this time we got a 302 redirect. This is the human readable form. This is the HTTP status code 302. It's just a redirect. It's saying, we're saying we want, give us slash at csusb.edu, and it sends us back and says, sorry, that's not, you don't want to ask for that. You want to ask for, and then it gives the location. It uses this location header to tell you where you should go. You should go to HTTPS www.csusb.edu. So look at that. The thing is, now we got to use HTTPS, and that's a secure version of HTTP. Now, this website, the university website, will only interact with browsers over HTTPS. It will only interact with browsers through a secure connection. Not all web servers require that, but our university does that. And I'll show you in the browser here. If I open this up, I'm going to paste that in. Look at this. This is HTTP. That's the protocol. See that? This is the URL. There's the URL right there. HTTP. I'm asking for HTTP. I want to go there. And I request it, and look, see, it's secure. Because it redirected us to, see that? It put the S in there. It redirected, because it will not send information over an unsecure connection, but not all websites do that. Let's take this crazy website here. MDM, I was trying to get to MDN, and this is funny, .com. This is an example. I thought I was going to go to Mozilla Developer Network, but instead I got to this Dearborn Single Muslims page. And look, see how it says not secure? it didn't redirect us. So it's allowing for an unencrypted transaction between the server and the browser. So not all web servers require that, but the university web server requires that. So this is how you look into these things. And I was tinkering, and I was going to show you how to make an encrypted connection and all that, but it's not really worth your time at this point, and so I'm not going to get into that. And I guess that's it. That's it for today. I'm just going to wind up there. So I'll see everybody in lab. Yeah. The people that go to lab today. I'll see half of you in lab today.
Oh, I would hope half of us.
Huh?
Depends on how many people stay in the class. I noticed a lot more empty seats today.
More empty seats today, really?
I stopped.
Oh yeah, it gets that way. You'll see it's going to drop quite a bit. Yeah.